Welcome to the third video in the Chapter 8 series, and this video is going to be on percent composition. For most students, this is probably one of the easier topics, which is always nice, and it's something that we've actually gone over before. One of these topics actually includes doing part over whole times 100, which we've done on labs a couple of times. So just for a friendly reminder, so percent composition is equal to part over whole times 100%. And for these questions, we're actually going to be getting the mass percent of a compound. The mass percent of a compound can be kind of written as the mass of the part over the mass of the whole. And of course, it's a percentage, so it's times 100. So when we were going over these before, we were doing it with experimental data where we had grams anyway. And in this case, we're actually going to use the formulas that we were solving molar mass for and solving for individual elements. So an example of a question that you would see, and we'll go ahead and put our question marks in on the end of these questions. What is the mass percent of sulfur in BaSO4? So if you watched the past two videos, I wrote out the way to write the molar mass in a specific way. I listed each individual element in a row, and I multiplied each individual component out, and then I added them together. There's a reason I did that, and that reason is for this type of question. So Ba is barium, and barium has a mass of 137.3. And sulfur has a mass of 32.07. All of these numbers are, again, coming off the periodic table. We're simply finding the molar mass. And oxygen is 16.00. So now we're going to look at what we have. We have one barium, we have one sulfur, and we have 4 oxygens. So I have 137.30. I have 32.07 grams of sulfur. And now I have 16 times 4 grams of oxygen, which is going to be 64 grams. So now I'm going to add them all together. So it's going to be 64 plus 32.07 plus 137.30. I'm going to end up with a total of 233.37 grams per mole. So now I'm looking for the percent sulfur. Percent sulfur is equal to whatever the sulfur number is, which in this case is 32.07. 32.07 grams divided by the total, which we calculated as 233.37 grams times 100%. So if you haven't noticed yet, the reason that I have you write them all out is that when you put in your calculator and you end up with this number, you now, in some cases, like we're going to look at in the next one, have lost what the individual element's mass was when you put it in the calculator and hit enter. So if you write it this way, you could actually solve for either barium, sulfur, or oxygen without having to re-put, for example, 16 times 4 into your calculator. So if I take 32.07 and divide by 233.37, I'm going to get 0.1374, and I'm going to end up multiplying that by 100, and I'm going to get 13.74%. So 13.74%, which makes sense, as barium has a pretty large mass, and oxygen is larger than sulfur. It should be a fairly low percentage, which it is. All right, so the next question is talking about the mass of phosphorus in Ca3PO42. So when I look at a question like this, the first thing I need to worry about is, again, where do the subscripts actually pertain and what elements do they pertain to? So for calcium, we have 3 calciums. This too pertains to phosphorus and to oxygen. So I have 2 phosphorus and I have 8 oxygen. So let's go ahead and work out the molar mass so that we can figure out how many grams of Ca3PO4 are actually phosphorus. So I have Ca, I have P, and I have O, so phosphorus and oxygen. And calcium has a mass of 40.08. And phosphorus has a mass of 30.97. And again, oxygen is 16.00. Again, calcium, because it has that subscript 3, is going to be multiplied by 3. Phosphorus is going to be multiplied by 2. And oxygen is going to be multiplied by 8. Fair warning here, the 2 does not pertain to the calcium. So there is only 3 calcium, not 6. So let's go ahead and calculate the mass for calcium. So it's 40.08 times 3, which gives us 120.24. Phosphorus is 30.97 multiplied by 2. And I get 61.94. And for oxygen, I get 16.00 times 8, which ends up being 128. I'm going to add all of these together. I'm going to get 128 plus 61.94 plus 120.24. I get a total of 310.18. And that's going to be grams per mole here. So the percent for phosphorus is going to be 61.94 divided by 310.18 multiplied by 100%. So 61.94 divided by 310.18. I'm going to multiply that by 100, and I'm going to get 19.97% phosphorus. Again, when you're going through these, remember that if you write it out in this fashion where you have each element, you have the mass and the number it's multiplied by, all you have to do is look for the element that the question's asking for. In this case, it's phosphorus. You're going to go all the way to the end. You're going to take that number and divide it by the total on the bottom. That way, one, you keep track of all of your numbers, and more than likely it'll actually avoid calculator mistakes, but it also makes your math easier, and you can actually solve for any of the elements equally as easy as you would solve for phosphorus. So I hope this also helps you solve for mass percent questions, and hopefully you'll tune in for our next video.